Hi everyone. Welcome to today's session on leveraging large language models, LLMs, for business use cases. We are at a turning point in AI today. For decades, humans had to adapt to computers, learning programming languages, writing complex rules, and structuring data in ways that machine could understand. But with LLMs, this is changing. These models adapt to us, processing human language with remarkable accuracy and speed. Imagine you run a business. Instead of spending hours analyzing customer reviews, emails, and support tickets, LLMs can do this instantly for you, extracting key insight, classifying text, and even generating responses for you. What you will learn today is how LLM work, why they are revolutionary, and how you can apply them to structure business data, not just raw text. Practical use cases like sentiment analysis on Amazon review is part of what we are going to talk about today. By the end of this session, you will know how to use LLMs on real-world business data with minimal code required. Let's dive in. I'm going to take advantage of Kaggle resources to teach you about LLMs. So let's first learn something about Kaggle and know what it is. So Kaggle is basically the playground for data scientists. It's a platform that different people can contribute to through data sets, competitions, models. They can access other people's data set or upload their own. So you can simply come here and create a new data set by as simple as drag and dropping a file like CSV. And you can define competitions and participate in one. So today we are going to use a specific data set on Amazon reviews for sentiment analysis for our use case. This data set basically has real customers' text reviews, their star ratings, and how other people found the review helpful in the columns. So it's basically a table of data that we can take advantage of. And this is really important for me to apply LLMs on tables of data because it is closer to real world application compared to just a single text. Oftentimes, you work with databases and tables of data in real world. So let's go through the notebook I have put together for you today. If you have worked with Python, you will find this notebook very familiar. This is practically a Jupyter notebook with code blocks and markdowns with embedded images. The big advantage of this is cloud-based. Everything is taken care of for you. Some of the most common packages like Pandas and NumPy come pre-installed, and you don't have to take care of the hardware either. So you have access to CPUs and GPUs and powerful ones. So this is really a good resource where you don't need to really be concerned about installation of Python and package management and all those time consuming stuff and dive right into the coding part. So I'm going to share the link to this notebook with you. And what you can do is create a copy of that for you that you can make any changes and play with. So basically, where I see the edit button, you are going to have a copy and edit, which is going to take you to this page where you get a copy of the full notebook and you can run all the different blocks of markdown and code. And you can also set up some of the settings of the notebook. Like over here, I have set the session option to use accelerator two GPUs. And the language is set to Python. And I have turned on the internet. You can see that you have going to have some quota on accelerators, and it is going to be 30 hours per week, which is pretty nice. But just make sure you turn off the accelerator when you are not using it, so you can save if you are frequent user. The notebook is organized as it's outlined in the table of content here. First, we are going to cover some key concepts like NLP, LLMs, transformers, and how we can apply these models through Hugging Face for sentiment analysis, text classification, for NER and summarization. And then we are going to use the Amazon dataset that we overviewed and apply it for business use cases like sentiment analysis. So let's get started. Uh, it's easy to imagine how important text data and interpreting text data is for businesses. A huge amount of text data is available through emails, reports, and customer feedback. And up until recently, these unstructured text data have been overlooked because it's hard to manage, and the natural language processing techniques is not really sufficient for taking the text and making some automated task or actionable insight very well. But with the advent of large language model, this has changed, and now it's really possible to take this text data and extract from it some actionable insights. And that's why, and this is because of the huge profit margin that businesses see in this LLM applications. They are pouring more investments into it, and you see it is very trendy right now. Um, Among some of the applications could be to get the customer reviews and avoid having to go through the manual analysis process, which is time consuming. It can be prone to biases. It is costly, and making it more scalable and automated through the use of large language models and prompt engineering. Before getting into the topic of large language models, let's familiarize ourselves with natural language processing, or NLP, which is the broader field of AI that enables machine to understand human language. It includes everything from rule-based models like spell checkers to more advanced machine learning techniques and deep learning techniques. Basically, large language models, or LLMs, are a powerful subset and a more recent subset of NLP. While traditional NLP used to rely mostly on statistical methods to extract meaning, LLMs take it further by using deep learning and a great amount of data to be generative models, to generate human-like responses and text. This makes them more capable and more human-like. Simply put, NLP is the foundation, and LLMs are the most advanced evolution of NLP, moving text processing into a new dimension. If you find yourself starting with this field and interested, I have provided links that you can read further about NLP and LLMs. But now, for the sake of time, let's move on to the next big word, which is transformers. At the core of large language models is a breakthrough model transformer. Unlike older models, transformers process the entire sentence at once rather than word by word, which used to be the case for LSTM models. This is thanks to a concept called self-attention proposed in a paper in 2017, which allows the model to focus on the most important words and how the words are connected. For example, let's say in a sentence, the movie was great, but the ending was disappointing. A good AI should recognize that great refers to movie, while disappointing refers to the ending. A good self-attention enables the model this level of understanding and correlating words together. What makes Transformer unique is first self-attention that helps the model focus on relevant words, parallel processing, which makes it a lot faster, with the help of GPUs and their scalability. Scalability enables transformers to be able to be trained on massive data sets and large corpus of data. And this makes them very powerful because the more data sets you can train a model on, the more knowledge you are instilling in that. So now let's take a look at the transformer architecture at the high level and understand the big picture of what is happening here. So I don't want to confuse you with the details here, but you can see on the left is the encoder and on the right is the decoder. And what is happening is the inputs are going into the encoder, and basically encoder purpose is to understand the input and turn them into their embedding and also some instilled understanding of what's inside of the input. And the right-hand side, the decoder, is the generative part. Is basically the autoregressive structure that generates text one token at a time. So this part of masked multi-head attention is responsible for autoregressive behavior and makes the model generates one token at a time while only considering past tokens and making it very effective for tasks like text generation and chatbot. Keeping this encoder-decoder structure architecture in mind, let's now talk about the top transformer models. So over here, I have listed the famous transformer models in sorted by their recency and their performance. I'm pretty sure that you have by now heard about and used ChatGPT, and the model behind it is transformer based and is called GPT-4. So this is best for chatbots, content generation, coding, and has high fluency and human-like reasoning. And you can see the architecture of that is based on the decoder only transformer. We have Gemini, which is multimodal, focuses on both text and images, and is great for multimodal AI task, which processes both images and text simultaneously. Both of the first two options are very powerful, but the downside is they are paid and they are expensive APIs. We also have Cloud 2, which is focused on ethical AI to reduce the bias and be more mindful of the privacy of the users. This is also paid, and the developer is Anthropic. We also have some lesser powerful but free options. In this list, we have Plenty 5 from Google, which is strong in summarization, Q&A, and structured NLP tasks. We have Llama from Meta and Mistral from open source, lightweight for and real-time NLP. So although we have ChatGPT and Cloud leading in fluency, Gemini for multimodal AI, but we have all sort of other models free and accessible through Hugging Face we are going to talk about next. But another thing that I want to point your focus to is the architecture column here. If you take a look, you will see a pattern emerges. There are basically three main types of transformer models. Some are encoder only, like Bert and Roberta. Some are decoder only, like ChatGPT and Cloud 2. And some are encoder decoder, like Plenty 5 and Gemini. So let's briefly talk about what that means. So encoder-only models are, in analogy, you can think of it as a reader. It reads the text at the input and it understands the text deeply, and then you can ask it some question or classification task or some sentiment analysis task. So they are perfect for understanding text and classifying it, and they are rich models for sentiment analysis, question answering, text classification, but they are not generative models. So they cannot be a chatbot. And some examples of that are BERT and Roberta. We also have decoder-only models like ChatGPT and Cloud. They are basically storytellers. They generate text word by word without thinking about the future or looking into the future. They are very good for chatbots and creative writing and for generative models like code generation, text generation, and all that. We also have encoder decoder, which is basically acts as a translator. You have some input that you first need to understand, then you can generate some structured response. They are great for translation tasks, for multimodal tasks. Like if you have an image, you first need to make sense of the image, and then you can turn it into some text or vice versa. And they are great for summarization. If you have a text, you first need to understand that text and then turn it into some shorter version. So the encoder understands, the decoder generates. If you find yourself less interested in the design intricacies of these networks and more interested in the applications of large language models, I have a good news for you. From this point forward of the lecture, we are going to focus on just that. We are going to see how we can apply these models without having to really deal with the layers that are taking care of the task for us. Basically, this is done through a very high level API, the pipeline function, which is part of Hugging Face. So this pipeline function is basically regrouping together all the needed steps to go from a raw text to useful predictions. You provided some task, let's say sentiment analysis, and you can either provide your specific model as an argument or just leave it to be the default one. And simply with that, you can apply the pipeline of the LLM on a text. So let's see that in practice and to see what I mean. So there are different tasks that we are going to talk about. Most of these tasks are pretty intuitive and you can understand what they mean just by the name of them. But let's go through the list and talk about them. Sentiment analysis is basically understanding the sentiment or the feeling behind a sentence. So you basically give a text to the model and ask if it has negative connotations to it or if it is positive. You can understand why this is important when you want to know if, let's say, a customer review has positive spin to it or negative, and you can do some business analytics over the result of that. Next, you can have a task like text classification, in which you can detect different classes. It can be detecting spams or fraud, or it can be any sort of classes. Basically, sentiment analysis is also a classification, just very specific sort of classification into negative or positive. So based on what you have trained the model on. It has specific labels and it is capable of labeling your text into any of those categories. NER is named entity recognition. Basically, you give a sentence to the model and ask the model to specify which words are some sort of entity, meaning there are people, location, or some organization. So it is going to extract key names and locations, brands, and organization names from that sentence. Summarization is clear. You give a longer text and ask the model to make it shorter. And you can also provide some argument of how you want that be done. Chatbots and AI assistants are the generative models, is basically where you give some sort of prompt to the model and ask for some story generation. So it's a text to text generation or purely text generation. So you set a task or a prompt for your large language model and ask for some sort of story to be generated or some sort of code to be generated. That's the chatbot. Zero shot classification is very similar to text classification, with the difference being that the model is not already trained on any of the labels. Like you are asking the model something new that it has not been trained on before, it's not fine-tuned for. So you like asking the model to categorize the type of reviews into whether they are quality, based on the quality of the product, whether they are customer service problem, or they are complain about price. So this is not something that the model is trained before for labeling, but this is zero shot classification. So a powerful model should be able to still classify a sentence without even being trained on that specific classification. That's zero shot. So now let's go through these in code. For that, I suggest that if you have not done so yet, you hit this edit, copy and edit, and let's run the notebook together. Once you do that, you get a copy of the notebook, which is owned by you, and you have full authority over. Meaning, if you double click on a block of markdown or code, you can make edits. For example, let's say I can write and make changes to it. And you can walk through this code, this notebook, through running the current cell here and manually walking through it. Or you can use some of the shortcuts like Shift Enter. Basically, Shift Enter is going to run the current cell and is going to jump to the next cell for you. Or you have the option to run everything at the same time, so that if some code block is more time consuming, it can take its time until you get there. Another thing that you have full control over is the session options. So if you don't see that, you can expand this sidebar through this little triangle thing. So you can expand the sidebar and you have access to some session options like accelerator. You can you see that I'm using 2 GPUs, which is a good idea for running LLM. Uh, it's going to make the code running faster. Uh, our code is in Python language, and we have also enabled access to internet. If we were to download something, it's going to make that possible. So this is just some overall view. And another thing you find in this sidebar is the input. So we have connected our notebook to a data set, which is Amazon data set. And if you hover over it, you see three dots appearing, and you can open that data set in new tab and walk through the specifics of this data set, what is included in it, and what are the columns, what are other people's code on this, so you can get inspired from other people's code. This is my code I just published, and you can sort it by number of votes to see the hottest notebooks on this data set and so on. So you get the idea. So you can add any input to your notebook, or you can upload your own data as well. So now let's make this uh, smaller and zoom in a little bit on the main notebook. So oftentimes the first code block is related to importing the modules. In Python, you have to import all the necessary modules for your task. And this is because Python is open source, and there are many different people contributing through writing code and packages that you can use in order to make your coding more efficient. So the first part of the code is where you want to import all the different packages that become relevant to you and you find useful for your task, so that you don't have to reinvent the wheel, so to speak. So this is the part that is of most interest in this um, notebook for us, is basically uh, the high level API that we talked about, that is going to include all the steps needed to take an input text and perform some kind of NLP task on it and give you the human readable output. So we are going to see how are the different ways that we can use this pipeline. So let's go to that part. We already talked about this overview. These are the markdown fields that you can also see how they are written if you are curious about that. Um, Otherwise, we are going to skip to the first use case of the pipeline, which is for semantic sentiment analysis. Basically, sentiment analysis is as simple as taking a text and telling you if it has positive connotation or negative. Or in some cases, it also has neutral as the label. So over here, we are creating the pipeline for sentiment analysis by this single line. It's going to take the task of sentiment analysis to the pipeline. And because we are not specifying any specific model, it is going to default to the default sentiment analysis model in the pipeline. And also, we can then, after creating the pipeline, we can input the text to that pipeline and get the result. So this is the input text. I absolutely love this product. It's amazing and works perfectly. So from our human perspective, this is a pretty positive sentence. So, and that's exactly what the machine thinks of this. The sentiment analysis pipeline also assigned 99.9% probability that this sentence is positive. So it's basically labels it as positive. So this is that simple. So you can apply uh, the pipeline on text very without having to deal with the intricacies of designing these models yourself or training these models. These models are already coming pre-trained. Another way that you can do this is through providing a specific model. So, if you are more curious about how to tweak this pipeline, you can certainly go to Hugging Face. Hugging Face is a truly remarkable resource where you can find open source pre-trained models on all different sorts of tasks. So on the left, you can see the type of task with different uh, general categories of multimodal, computer vision, natural language processing, and so on. And you can go to a specific subcategory, like let's say within natural language processing, you can select text classification. And this is a list of all different pre-trained models that you can take advantage of. You can simply grab the handle, copy it, and take it into your notebook and use it as your own model. So simply, I'm going to copy and paste over here, and you will see just as simple as that, it is going to take care of getting all the necessary components of config files and the weights and tokenizer and all these sort of stuff, downloading them, putting together, and simply performing the task that I'm interested in. So you don't really need to know any of these details except that which model you are interested in and which task you are interested in. Or another interesting task you can perform is text classification. For example, let's imagine you have a model for spam detection. So your model is already pre-trained on this task of detecting spam and fraud, and you can use it to automate that workflow. So basically, this is one such model that I simply found by searching for spam detection models in Hugging Face and providing that model over here. So once you run this and provide this text which says, "Congratulations, you have won a free iPhone. Click here to claim your prize," you will see that this machine can use this model to uh, find the label correctly as spam with 99% of accuracy, certainty. So this is going to be really interesting for automating the spam detection pipeline. Another task you can use is named entity recognition for extracting key details from a text. For example, from the sentence, "Apple was founded by Steve Jobs in California," if you apply the NER task on this sentence, we expect all the organization names, people, and places to be recognized. And this is exactly what the pipeline does for us. So over here, we see that Apple is the word that is recognized as an organization. We have Steve Jobs being categorized as a person, and we have California that has correctly been labeled as a location. So this is pretty cool and shows the level of understanding that the model has of language. So with all these examples, you get the idea of how you can apply this pipeline to simply run different tasks. And now I want to show you one cool thing that is instead of simply applying this pipeline on a single sentence like this, you can apply it on a full tables of data. And that takes the how powerful these pipelines are to the and whole another level, and makes it even more powerful because you can then apply it on a full database and automate some kind of task. And that's exactly what we want to use the Amazon dataset for. So Amazon dataset has a table of real customer reviews. You are already familiar with Amazon reviews. There are some written text as well as some star ratings, and also other people can rate your review as helpful or not helpful. So we are going to use that table, which looks like something like this. The main column that we are interested in is the review text, which has the text of the review. And also, we want to only consider those reviews that at least one person found helpful, so that we are not going to go through some junk thing. So over here, we are applying the filter and also some slight pre-processing. Like I want to replace the rating number, which is a number between 1 and 5, with the number of stars by this simple function that multiplies a star sign with the number in the rating, just for the looks of it. And I'm also going to apply the filter that I mentioned based on the helpful reviews, because I just want to filter the reviews to those that at least one person found helpful. Doing that, we get to have 413 rows or text reviews. And now let's see if we can apply the sentiment analysis on the full column. In order to do that, if you are familiar with Python, you know that you can use pandas and the apply function to create a new column based on another column very easily. So basically, you take the review text column and you are going to apply the classifier, which is a pipeline built based on the sentiment analysis on that, and save the result in a new column, which is sentiment. Just as simple as that, you can see how this works out. And what we are doing here, we are using the default sentiment analysis model. And you see, this is kind of shaky the way that it has worked, because I expect when the sentiment is categorized as negative, we see lower number of rating stars, and this is kind of uh, making me doubtful. So that's why I'm going to go with a better model. So I'm going to specifically pick a better Roberta sentiment analysis model and see how that works out, comparing it, sanity checking it with the star ratings. So doing that, you will see that this new model, this sentiment 2, is a lot more sensible. Let's walk through one of the examples. So this is saying that it came fast with no issues. So, and the rating has 5 star. So I expect it to be positive in sentiment. So I trust this second column more. And another way to make sure that this makes sense is through seeing it, visualizing it in a plot. So on the left, we have the first sentiment analysis using the default pipeline, the default sentiment analysis model. And you see it's still showing the same thing that throws out some suspicion. because we have so many high ratings, these green ones, being assigned negative sentiment label. But in the sentiment 2 column, which is the model that we specifically picked, we see a better classification happening. So you see most of the low ratings are actually classified as negative sentiment, some neutral, and we like neutral label in the default. That's another disadvantage. So we have three labels here, and most of the high ratings are classified under positive sentiment, which is nice. So that's the first task that we simply, with one single line, just as simple as this, applying the sentiment analysis function on the full column of review text, we could do this, we could automate the analysis of sentiment. And this is very powerful. So another thing that I want to show you is how, and I have the visualization of this over time, so you can see, because we have another column of date in the reviews, so we can see the trend. Let me zoom out so you can see the full plot. So using the date of the review, we can see how the sentiment has evolved through time. And if we can find any specific pattern of having some more positive reviews evolving or some negative ones. So that's also to check the trend. Another task that I have applied here, which is a very useful one, and many businesses are looking for this, is explainer. People really like to be able to explain why the model is coming up with a specific label. So without that explanation, people are usually suspicious. So what you can do is you can have a chain of large language models, so that you can, after you have applied the sentiment analysis, you can apply a next task of question answering, so that you can ask why do you think this review has been assigned this sentiment. So doing that, you can get some sort of explanation, and you can see this is pretty cool. So for example, for the sentiment of a positive sentiment review, this is the explanation that the large language model has come up, because it is fast and no issues. And this is another one. My rating would remain unchanged, speedy, responsive, and meets my needs. And for this is one of the negative. It will not go up to a speed or throughput. So this is very interesting, that you can not only you can apply some task, but you can have some chain of tasks that can make the large language models even more trustworthy and useful. I have one last example of how you could use LLMs on this data set, and that is to use it for zero-shot classifier. As I explained before, zero-shot classifier is a task that you provide the labels without the model being trained on those specific labels. For example, over here, the categories I'm providing the model with are price, quality, and customer service. So I want the model to read the review and, based on its best judgment, assign one of these categorical labels to that review. So the model is not trained on these specific labels. And let's see how it's going to perform. So doing that, you will see that, for example, for this, we have something mentioned of the price, and the category is correctly assigned to price. Or, for example, this is assigning customer service, and it's a negative review. So it's going to be a harder task for LLM because we have not fine-tuned or provided any examples for this task, and it's a new task. But still, we see some pretty acceptable performance. And if I plot the distribution, you can see that we have most of the reviews as talking about the quality of the product, some about the price, and just a smaller amount of them talking about the customer service. So overall, I want you to take home from this lecture how you can get started with applying LLMs to automate different tasks that you have or the businesses that you work with have. And this can be anything from sentiment analysis, text classification, adding explainability, adding a chain of large language models together to make it even more powerful. And I really encourage you to get us started with using Hugging Face today because it is an exceptional resource, and I'm sure you are going to find it useful. I hope you take something away from this lecture, and I hope I see you next time.